Hi, I'm Ed Maureen, an engineer at Agilent Technologies. I am here today to talk about the challenge of improving test throughput and also about Agilent Technologies' advanced power system. This is a family of 1 and 2 kilowatt high-performance DC power supplies designed to overcome your toughest test challenges. In manufacturing tests of electronic products, improving throughput is paramount. We've had customers tell us by cutting just a second of test time out of their test process can save them thousands of dollars. One thing you should consider for throughput is the power supply. It can drastically impact your throughput as products are tested at various voltage levels and for a variety of operating conditions, and this adds up to quite a bit of test time. I've created a benchmark program here to quantify and demonstrate the performance of the throughput and how using an advanced power system power supply can provide a 10-fold improvement over throughput over a basic supply. Let's take a closer look. For my benchmark demo, I have a general purpose power supply, an advanced power system power supply, and my benchmark programming running on my PC. The benchmark program evaluates the throughput performance of the power supply based on its command processing time, its up and down programming speed, and its measurement speed. The program works by sequencing through a series of voltage steps and making a current measurement at each of these levels, as you can see in this oscilloscope capture. The program then determines the average time it takes for this test to execute. This is just as comparable to when you test your device in manufacturing at many different voltage levels and operating conditions. So first, let's look at a general purpose power supply performance to compare its throughput to that of the APS power supply. To run the benchmark program, I need to enter appropriate values for quantifying the power supply's throughput performance. For the basic power supply being used, I've entered 80 milliseconds and 150 milliseconds for the up and down programming speeds. The measurement aperture time is set to 6 power line cycles, which happens to be a fixed value for the basic power supply. I can now start the benchmark program to see how long it takes. From running the benchmark program, I find it took on average 5.4 seconds for the basic power supply to execute the benchmark test loop. I now need to repeat the benchmark test using an advanced power system DC power supply. For this power supply, I've entered 1 millisecond each for the up and down programming response times. This is about 100 times faster than the basic power supply we just used. I have set the measurement aperture time to 1/10 of a power line cycle. This is a programmable parameter on the advanced power supply, and it can be optimized for throughput and performance. Now I can rerun the program to see how the APS power supply performs. With the advanced power system power supply, I find it only took 0.58 seconds on average to execute the benchmark test loop. This is a 10-fold improvement over what we saw with the general purpose power supply, and this was just simply substituting the advanced power system power supply in place of the original supply. There are additional features within the advanced power system power supply that would allow you to even further optimize throughput if you like. When challenged to improve throughput, which is always the case in manufacturing tests, using the Agilent Technologies advanced power system can make a dramatic improvement in throughput, as you saw here in my demonstration today. For further information on the advanced power system DC power supplies, please follow the URL on the screen provided. Thank you for your time and interest.